So today we're going to talk about the properties of logarithms. There is a product property, quotient property, power property, and then there's one other one too that we'll be looking at. So the first thing we're going to look at is what's called the product property of logarithms, and that's where we can actually combine them together depending on the situation. So the product property says that if I have the log of m times n, so the log of a product, then I can take those two factors of that product and I can write them as the log of m plus the log of n. So basically this is the rule of exponents that we looked at first, to where if we're multiplying with the same base, we add the exponents. Well, it works the same way here. If I'm multiplying these two things together, then I can pull them apart and write them as an addition problem, or go the other direction also. So this is the product property. The log base b of m times n equals the log base b of m plus log base b of n. And they must be the same bases throughout this situation. Okay? So here we've got the log base 6 of 4 plus the log base 6 of 9. They want us to express it as a single logarithm and then simplify it if possible. So we're going to be using our, hopefully doing some of the mental math that we did on Friday with finding logarithms once we've simplified it. So since we are adding here, that means that the product property applies, and so we can write this as the log base 6 of 4 times 9. So since we're adding two logarithms with the same base, we can rewrite that as a single logarithm with the same base and those two numbers 4 and 9 multiplied together. So this would be the log base 6 of 4 times 9 is 36. And then we want to simplify if we can. So 6 raised to what power is 36? Okay, to the second power, right? Because 6 squared is 36. So we could rewrite that as 2. So we've done two things here. We've written it as a single logarithm, and we have simplified it. So whenever there's a plus sign between them, the bases are the same, then we can multiply these two parts together. So combine them as a single logarithm, and then if possible, use our exponents to simplify it. Okay, so there's the product rule. Next one is the quotient rule. The quotient rule applies when we have dividing with the same base. We subtract the exponents. So the log base b of m over n is equal to the log base b of m minus the log base b of n. Excuse me. So if we're dividing, or I should say if we're subtracting, then we're going to divide them. All right, that's the quotient rule. The property can always be used in reverse order, but just remember, as a to the fifth b cubed cannot be simplified, logarithms have to have the same base. Now, Lots of times you can probably type it in your calculator and get an approximate answer, but we're normally not going to do that. So here we have the log base 5 of 100 minus the log base 5 of 4. Now it's okay to use your calculator to check these, but I don't want you using your calculator to do them. Okay? So since we are subtracting here, that means that we will divide these two numbers with the logarithm. So we have the log base 5 of 100 divided by 4. And lots of times you shouldn't even need your calculator. So what's 100 divided by 4? Okay, 25. So log base 5 of 25. And 5 raised to what power is 25? 2. All right. So here we've got we wrote it as a single logarithm, and here we simplified it to get 2. So the biggest thing is making sure you don't mix these properties up. So how about this one? Right. Next rule is the power property. And the power property says that if we have an exponent, we can take that exponent and move it to the front. We can take that exponent and actually take it to the front and make things easier for us. That's the power property. So we can see at the log base b of a raised to the power of p, and then we take that p and move it to the front then, so that we make it a multiplication problem then with that. All right, so like here we had the log of 10 cubed, well that's the same as the log of 10 times 10 times 10, which since I'm multiplying here, I can change these to addition, then the log of 10 plus the log of 10 plus log of 10, which actually just means 3 times each of them. So using that power property, we can take that exponent and move it to the front. So we'll look at a couple of examples for this then. So we'll take the 6, move it to the front, becomes the log 6 times the log base 2 of 32. Take that exponent and move it down in front of the logarithm. So do we know what the log base 2 of 32 is? Can I take 2 and raise it to a power and get 32? Okay, how many times, Joe? 5 times, all right? So this part here is equal to 5, so we have 6 times 5 is 30. All right, so we used the power rule, so expressed it as a product, 6 times the log base 2 of 32. Simplify the log base 2 of 32, and we get 30. Okay. So letter B, we can take that 20 and move it to the front. So we get 20 times the log base 8 of 4. Now, since I can't raise 8 to a power and get 4, actually I can, but it's a little bit it's not so easy. Then in this case, this would be one where you're probably just going to type it in your calculator to find out what that is. So I'll just take my calculator and do 20 times the log base 8 of 4. Now, we're going to talk about this later. We were going to, but since it really doesn't affect as many of us, We'll talk about now as far as where Shelby is concerned on her calculator, because she has an older calculator. What she will have to do is 20 times the log of 4 divided by the log of 8. Remember we wrote that rule down the other day? Okay, same thing. Basically, they call it a change of base rule. All right, so we're changing the base to 10 from 8. So David, what'd you get? 13.3. Okay. So 13 and 1/3, right? All right. Oops, I guess I don't need a decimal point if I'm writing a fraction. All right, 13 and 1/3, or which was the same as 40 over 3, because this is actually the log base 8 of 4 is equal to 2/3. So we do 20 times 2 divided by 3. Okay. All right, so power rule, move it to the exponent to the front, then we have a multiplication problem then. All right. So go ahead and this one, next one is called the inverse properties, which basically just kind of applies to what we were just talking about when we have the same base as the thing next to it, as those are the same. Just the thing is that whatever the exponent is what we get. So we've got here the log base b of b to the power of x just equals x. So whatever the exponent is, it equals. Right? So these exponents, or these bases, basically what they're going to do is they're going to cancel each other out in a way. So when these two things are the same, right, or here, they kind of undo each other because they're inverses, so then it's just going to equal x in both of those cases. Right? Just like here, so log base 10 of 10 to the 7th power, since these two 10s are the same, it just equals 7. The base here is 10, the base there is 10. So since they're the same, they're inverses of each other, it just equals 2. All right, so that's the inverse property. All right, so we're looking for the bases then. So here we've got both of these bases here are 3. So they're inverses of each other. So this just equals 11. We'll come back to B. C says 5 raised to the power log base 5 of 10. So the two bases are the same. These two things are both 5. So those undo each other. So this just equals 10. All right. And letter B, I'm not sure where that one applies because, well, I do, because we could rewrite this as a log base 3 of 3 to the 4th power, which then just equals 4. But I would say, hey, that's 3 raised to what power is 81 to the 4th. And like I said, I want you to do as many of these as you can without your calculator. But if you can't, okay, if you need assistance, use your calculator, all right? But try to do them without, first of all. Okay. This is one that I was talking to with just for Shelby because her calculator does not doesn't have that log function on it, the older calculator. So she actually has used what's called the change of base formula. I'm not going to go into the explanation of that. Just that's all you need to know is that if you've got here the log base 32 of 8, then you do the log of 8 over the log of 32. So the base always goes in the bottom, okay, the denominator. Okay, and that's it.